Hi, good morning, ma'am. My name is Manikant Reddy, Cybersecurity Section A. Number is 22951 A6238. So today I want to explain my tech talk question. Uh, the topic was poison law and informative theory. So let's go into topic clearly. Okay. Why we need to what is Poisson distribution? Poisson distribution is a limiting form of binomial function, binomial distribution in which n, the number of trials become very large, and p, the probability success of event is very, very small. Okay, you have understood that it's a binomial distribution which n number the cases become very large and probability also the probability success of an event very, very small. Okay. Okay. History. History about Poisson's law. The distribution was derived by French mathematician Simon Poisson. Poisson's law was introduced by Simon Poisson in 1837, and the first application was the description of number of deaths by horsing kicking in the Prussian army. Okay, the who is the mathematician was proposed this Poisson law? Simon Poisson in 1837. The first application was the description of number of deaths by horse kicking in the Prussian army. Why we need Poisson distribution? Poisson distribution used in cases where the chance of individual event being a success is very small. The distribution is used to describe the behavior of rare events. Poisson distribution used in cases where the chance of individual event being a success is very small. The distribution is used to describe the behavior of rare events. Like examples, the first example is the number of defective screws per box of 5,000 screws. Like if you bought 5,000 screws in a box, we had the number of defective screws is a Poisson distribution. Is a first example. And second example is the number of printing mistakes in each page. The first proof of a book. The exam the number of printing mistakes in each page. So uh, in each page, we don't know how many printing mistakes are there. Here, in first slide, what we learn the which number of tries become very large and probability success is very small. Okay, here, the number of accidents in India in 1 year. Accidents are occurring more. So this is the one Poisson distribution. Occurrence of number of scratches on a sheet of glass. This is also another example. Use of Poisson distribution in paramedical. Paramedical means what? Like doctor, medicines, hospitality. This Poisson distribution also used in a paramedical also. Uh, we learn in what way they will use. Control limits of a number of tablets rejected from an online. metal detected during table compression cycle, microbial counts in raw materials, uh, products, and water for paramedical use. Control limits of for number of containers rejected from visual inspection of sterile production batches. Alert limits for microbial levels in clean room environment. Release limits for microbial counts in non-sterile products. These are all the uh, uses of poison distribution in paramedical, like a hospital, like this. Okay, the poison distribution mathematically, it is also a probability, but it has some formula. This is a formula. So just I want to note. So this is the formula. P of x equal to e power minus m into m power x by x factorial. This is the Poisson distribution formula. Wherever the number of trials is very large, we will use this Poisson distribution to find the probability. Okay, probability of a particular, like any statement. Okay, here is the formula. P of x. Here x means what? Random variable. Okay, equal to e power minus m into m power x square x factorial. Here e means what, n means what, x means what. We have to learn. Okay, where x equal to 1, 2, 3, 4, like natural numbers. X equal to here x, here x. This is the natural numbers. E value we know. We all know 2.7183. Okay. M. Here m is there now. E power minus m, m power x. Okay. The mean of a Poisson distribution. That is average number of occurrence of an event. Average value or mean value of a occurrence of an event. This is p value what, 2.7183. Okay, m value is what? M value the mean of Poisson distribution or average of number of occurrence of an event. X is what? X is a number of the trial, means natural number. Okay, we have to erase all this. Okay, next we are going very next slide. Condition under which Poisson distribution is used. In what condition Poisson distribution will be used? First one, the random variable x should be a discrete, not continuous. It will be a discrete, means it will be uh, different. Random variables must be different. It will not be the same. Okay. Dichotomy exists, that is happening of an event of the event must be of two alternatives such as success as a, and failure. Application is those cases where the number of trials n is very large and probability of the success p is very small, but the mean np equal to m is finite. Okay. Application, one of the most important application is number of trials must be very large, but probability of a success p is very small. The mean np equal to m is finite. Statistical independence is assumed. These are the four conditions under which Poisson distribution is used. Characteristics of Poisson distribution. Characteristic. What are the characteristics of Poisson distribution? We will see now. Poisson distribution is a discrete distribution. Okay. In previous slide also, we have condition is there. Random variable h should be discrete. So Poisson distribution is a discrete distribution. It depends mainly on the value of mean m. It depends mainly on the value of mean m only. This distribution is positively skewed to the left with the increase of values of mean m. The distribution shifts to the right and skewness diminished. If n is large and p is very small, the distribution gives a close approximation to binomial distribution. Since the arithmetic mean of a Poisson is same as binomial, Poisson distribution has only one parameter m. The arithmetic mean that the entire distribution can be determined. Uh, one, one the arithmetic mean is known. Okay. The Poisson distribution is a discrete distribution with a single parameter m. As m increases, the distribution shifts to the right. All the Poisson distributions is skewed to right. This is the reason why Poisson's probability distributions have been called the probability distribution of a rare events. Here, from this, we'll see the problems. So before going to the problem, we will revise the concept before going to the slides. Okay, I will see I will show you the slides. You only revise it. I hope you all revised the concept. Here is the first question. Average number of accidents at a particular intersection every year is 18. Average here given M. M value is given. Average number of accidents per year is 18. So we have to calculate the average number of accidents per month. Okay. Per month is what 18 by 12 is equal to 1.5 accidents per month. Okay. Uh, First of all, we have to calculate the probability that there exactly two accidents there is a month. What is the probability? Probability of finding exactly two accidents per there is a month. In any month, the two accidents will occur. So what is the probability? Here e power minus lambda, lambda for x e power minus lambda, lambda for x by x factorial. So here lambda is the average. X is the uh, how many how many you want. Okay, e power minus 1.5 into 1.5 whole square by 2 factorial. That is how much? 0.2150. Here, calculate the probability that there is at least one accident this month. At least one. So, at least one means what? At least one means one, two, three, four, like that. So, we have to calculate the zero accidents in a month. E power minus lambda, lambda for x by x factorial. So, zero accident probability of zero accident will be 0.22313. So, P of x squared at least one means what? At least one means one or one above one. So 1 minus p of x equal to 0. Here is the answer. So what is the probability that there is and more than two items? Means what? P of x greater than 2 means what? 1 minus p of x less than or equal to 2. This is how we calculate the probability. This is thank you very much. Thank you so much, ma'am.